Welcome to the concept video of basic electrical engineering. Myself Sanjay from CSIT branch, and my topic is numerical problems on the KCL. Before directly going into the KCL, let's know the basic definitions. First, what is meant by current? The current in electrical circuits. Flow of current from positive terminal to the negative terminal. Actually, it is like a flow of electrons. Okay, and the units is amperes and measured using ammeters. And voltage, energy required to move a charge from one point to another. And the units of the voltage is volts and measured using voltmeters. Think of voltage as what pushes the electrons along the circuit, and current as a group of electrons that are constantly trying to reach a state of equilibrium. And Ohm's law, current through an ideal conductor is proportional to the applied voltage. Conductor is also known as resistor. An ideal conductor is a material whose resistance does not change with temperature. For an ohmic devices, voltage is equals to current into resistance, that is V is equals to IR, where V is voltage, I is current, R is resistance, and V is voltage units are volts, current units are amperes, and resistance units are ohms. Ohm's law continues. The total resistance of a circuit is dependent on the number of resistors in the circuit and their configuration. And the R equivalent in the series circuit is R1 plus R2 plus R3. For example, R1, R2. In series connection, the equivalent resistance is R1 plus R2. And whereas in parallel series, think it as R1 and R2. The equivalent resistance in parallel is 1 by R1 plus 1 by R2, that is R1 plus R2 by R1 R2. The sum of the resistors by product of the resistors. And the Kirchhoff laws are two types. There are Kirchhoff's current law and Kirchhoff voltage law. First, these laws are first derived by Gustavo Robert Kirchhoff, and hence these laws are also referred as Kirchhoff laws. And these are the basic definitions that are useful. First, actually, we are going to know about node, any point where two or more circuit elements are connected by together. For example, we can take here this point, and this point is called as nodes because here more than two elements are connected. Like here we are connecting three resistors at a point, and that is R1, R2 and R3, and this is node 2 where R3, R5 and R4 are connected. And a branch, a circuit element between two nodes. And the circuit element between the two nodes means the area between the area the circuit elements between the two nodes is called as branch. Loop, a collection of branches that are formed closer path returning to the same node without going through any other nodes or branch. Example, this is called as one loop, this is called as second loop, and this is called as third loop. And we are ideal voltage and current sources. Voltage sources are denoted by like this, and the current sources are denoted with an circle with arrow. And we are going to know the definitions of the KVL. The algebraic sum of all voltages around a closed loop must be equal to 0. Voltage drop, summation of voltage drop minus voltage rise equals to 0, or voltage drop equal to summation of voltage drop equals to summation of voltage rises. That means V1 plus V2 plus V3 so on up to V1 minus V1 M1 minus V1 M2 V1 M3 minus V1 N equal to 0. So according to Kirchhoff's second law, that is sigma V equal to 0. And the KCL, the algebraic sum of the currents entering a node is 0, and each branch current entering the node, and subtract each branch leaving the node. Sigma current input minus sigma current output equal to 0. For example, let's take an I1 sorry, I1, I2, I3, I4. KCL states that the algebraic sum of the current entering into the circuit is equal to the uh, current passing out of the node, that is I1 equal to I2 plus I3 plus I4. Okay, then the sum of all currents is 0. This can be generalized by sigma I equal to 0, and we are going to see some numericals of KCL. Here we need to find the total currents passing through the resistors. Node 1, node 2, there are two nodes, and the currents are 1, the currents at the node. The nodal equations, we assume all currents are leaving the nodes. Okay, v1 minus 12 by 1. Okay, v1 minus 12 by 1, v1 minus v1 minus 5 by 6. Okay, and v1 minus v2 by 2. It is one equation, and at the second node, same as the first one, v2 minus v1 by 2, v2 minus v1 by 2. Okay, and v2 by 5. Why? Because there is no voltage source at this direction. Okay, v2 minus 5, and v2 plus v2 plus 10 by 4 plus 3 7. Okay, v2 plus 10 by 4 plus 3, that is v2 plus 10 by 7. And rearranging terms according to the given equation, 10 v1 minus 3 v2 equal to 77, 35 v1 minus 59 v2 equal to 100. Or we can solve this equation by using Cramer's rules, or simply we can use the calci. By using the calci, if we calculate this, we are going to get v1 as 8.748 and v2 as 3.495. And calculating the current, according to the Ohm's law, V equal to IR. If we substitute V and R, we can get the I value. Okay, and the second one, find the current I0 and voltage V0 in the circuit shown below using KCL. And these are the current sources at node A: 0.5 I1, 0.5 I1 plus 3, this is in opposite direction, minus I0 equals to 0, 3 minus 0.5 equal to 0, and the I0 value we are going to get is 0.5 by minus 0.5 I0 equal to minus 3, and I0 equal to 3 by 0.5. After calculating, we are going to get the 6 ohms, and V is 4 ohms, 4 into I0, and that is V equal to IR. We know the I value and we don't know the V value. We know I and R value. The product of two will give the v value, that is 4 6 are 24. And the third one, in the below given diagram, find the current through R1 and R2 using the KCL. Current flowing through R1 and R2 using the KCL. First, we are going to find out the nodes. There is one node. Okay, and we are writing the equations. That is I1 and I2 minus I3 equal to 0. The voltage at node 1 N1 is V1, and the magnitude of I1 and I2 can be determined by I1 equal to V1 minus 20 by 50. Okay, I1 I1 equal to here, and I2 is 4 amperes. I2 is 4 amperes, and I3 is V1 by 40. Why? Because this is in the downwards direction, V1 by 40. Putting the values of I1 and I2 and I3 in the equation 1, we get I1 plus I2 plus I3, that is V1 minus 20 by 50 plus 4 minus V1 minus 40. By solving this, we can get the values of V1 equal to 720, current to resistor R1, current to resistor R1. Okay, I1 is equals to V1 minus 20. We know the V1 value is 720 volts. Substituting in this equation, we can get that 720 minus 20, 700 by 15. The I1 values is 14 amperes. Current to the resistor R2, that is in 40 ohms. We know that A2 okay. Current to resistor R2, I3 is equals to V1 by 40. I3 is equals to V1 by 40. We know the V1 value is 720. By substituting in 720 by 40, we can get 18 amperes. And I1 plus I2 equals to I3. That is, the KCL equation is verified. The 14 plus 4 equal to 18. 18 equal to 18. Hence, the KCL is proved. That is, the current entering to the node is equal to the current exiting through the node. Find the current to the 20 ohm resistors and current to 40 ohm resistor. The first at, at first we are going to identify the number of nodes in a circuit, and then we are writing the directions of the current, and then we are forming the equations, and after that we are going to calculate the values, and we are going to find the current to the given resistors. Okay, writing the KCL at node X, that is minus I1 plus I2 is equal to 2 amperes, and write Vx in the circuit using the Ohm's law. V equal to IR. I1 equals to 12 minus Vx by 20. 12 minus Vx by 20, and I2 is equals to Vx by 40, because there is no voltage source here. Apply by solving these two equations, we get the Vx value as 34.67 volts, and the current passing through the 20 ohms resistors is, we are going to substitute in the formula, that is here 12 minus the answer we got 34.67 by 20 equal to minus 1.133 amperes, and the current through a 40 ohms resistor, same by applying in the formula. We know the formula, that is Vx by 40, that is 34.67 by 40, it is equals to 0.866. Okay, and determine the current through the 800 ohm resistors in the network shown in the figure. We are going to find out the resistor current flowing through this 800 ohm resistor. Firstly, we are going to find the number of nodes in this equation. Okay, node 1, node 2, and node 3, and writing the KCL values at node 2, that is V2 minus V1 by 50, V2 minus V1 by 80 plus V2 minus V3 by 800 plus V2 by 750 equal to 0, and simplifying this equation, we get as 1.508 V2 minus 0.125 VA V3 equal to 5, and same we are also applying at this node 3, uh, and after writing this, we are going to get the equation is minus 0.125 plus 0. V2 V3 equal to 0, and solving this both the equation 1 and 2 using calci, we can get the values of V2 as 3.617 and 3.632, and I equal to V3 minus V2 by 800, and substituting the V3 and V2 for value by 800, we are going to get the answer as 2.04 amperes. And I conclude that Ohm's law, Kirchhoff's laws, and Kirchhoff's voltage law are essential and the most basic techniques for the analysis of the linear circuit. Using three laws, any resistance of current through or voltage across a resistor can be found if any two are already known. Thank you.